Hello everyone and welcome to this YouTube video. In our previous video we talked about the issue of overfitting and underfitting, and in this video we'll fix that issue and we'll talk little bit about how we can regularize our cost function. So first of all, let's see what there are two ways for fixing the issue of this. The first one is we have to reduce the number of features, and the first one is little bit, I think it's not perfect or not a good approach if you have so many features and they are important. So you don't have to remove the feature, and if your feature is something like very unnecessary for your model, then you can remove it manually. Or if your whole feature is very important for your prediction value, so it's not a good idea to remove one of the features which are very important. Okay, so first one is a good approach for only if you have columns who is unnecessary for your data, unnecessary for your model. Okay, and the second approach is what I like is using our regularization parameter, which is often called lambda. Okay, and we'll talk about lambda just in a second. Okay, so first of all, let's see how we have a cost function that we have talked about. Let's see how we can regularize our cost function, and in our next videos or the future videos we'll talk about regularizing our linear regression algorithm and logistic regression algorithm. So first of all, here we have a complex quadratic equation. It means there are so many features. Think of it as there are so many features. So 1, 2, 3, 4, 5, 6, 7, and here we have so many features. And what can you do is that you can just remove one of the features, just like this theta 5 extra x superscript 5 or theta 6 x superscript 6. We can remove this if these features are invaluable for a model, and if it is not, we have to use the regularization parameter. Or what we can do, if I talk about specifically for this equation, what I can do is that I can just simply this theta subscript 5x, this is the input. Okay, this is the input that we have to regularize. So I can what I can do is that I can simply make this near to 0 equals to our theta approximately equals to 0. So I can do that. So specifically for this equation, I have written down the equation. Well, what is that? We have our cost function, and what we are doing is that we have a cost function, and plus this kind of is very not eliminating our theta subscript 3. It is just making near to 0, and also for theta 4. And you might be thinking, hey Ayush, what are you talking about? I'm just confusing. So wait for some time. What I'm telling is that these two, we have to either eliminate this features or either reduce it to 0. And this is not necessary that it can be very important for our model, so we can't eliminate it. The only thing left is that we can reduce it approximately 0. So we can simply multiply it by 1000 and square it. Just think of it as something like that. And here we are talking specifically for this equation, and now let me give you the perfect equation and the single summation you can do or regularize your whole parameters. So here we have our regularized cost function, and you might be seeing here that I have added some set of hyperparameters here, that is lambda. And what is lambda here? I will get back to lambda just in a second, and you might be thinking that here we have to go from 1 to n for our theta values. And our previous we have theta 3 and theta 4, and in this it can be theta 1, theta 2, theta 3 all the way to theta n, and we have to regularize it and make it near to 0. Okay, so you just understand it, just this for making regularizing it with a hyperparameter lambda. And what is this hyperparameter lambda? So let's take a look at the hyperparameter lambda. So here we have a lambda. It helps us to smoothen our hypothesis output so that it will less prone to overfitting. And what I can do is that I can simply regularize it if I choose lambda equals to 1000. Lambda equals to 1000, that I have just 1000 multiplied by theta 3 times x3. Okay, and if I choose 10,000, it can prone to underfitting, and it will not perform well on the particular data. Okay, so we don't have to choose the large, we don't have to choose the very small, we have to choose them at a good lambda. Usually I took 1000, and it's totally based upon your problem, what kind of machine learning model you have. Okay, so I have talked about the lambda, regularizing, cost function, etc, etc, and these are pretty much easy. You can understand it very well. If you haven't, be sure to rewind this video and try to understand, and if haven't, please comment it down below so that I can understand your problem and make it clear to you. Okay, now in the next video I'll be talking about the regularizing linear regression and logistic regression, which are the algorithm. Okay, so in my next video I'll be talking about that and making you more clear about the regularization. And also I have talked about the lambda, which is a very important hyperparameter, which you have to tune it and check if your model is based on the particular lambda or not. Okay, so thank you for seeing this video, and I hope that you enjoyed this video and gained something knowledge from this video. I'll be catching up you in my next video. So meet you in the next video. Till then, bye bye.